Okay, guys, so this is a review of lesson 2. This is your homework sheet that you are completing tonight and turning in tomorrow. I'm going to kind of show you how to set these up so you can kind of get a feel for that. I'm not going to give you the answers because I do want you to try them, and then when you turn them in tomorrow, I'll check them and hand that back to you. So I'm just going to kind of jump right in. And I'm looking at number 1. There are 4 problems to do for number 1. It says show each expression on a number line and then solve. So we talked a lot about that today with showing a number line. And some of you, it kind of confused you, but that's why I'm doing this video, to kind of help you out. So I'm going to first start off by drawing my number line. Okay, and as you can see, my denominator is 9 in both of these. And now we can simply add this and say that 4 plus 1 is 5, excuse me, and our denominator will be 9. So we already know what our answer is, or our sum of these two fractions is. But if we were to put it on a number line, we're going to start by on the left, because we read left to right, and this is going to be 0. Over here is going to be 1. So a fraction is a smaller part of a number. Okay, so we've got all of these fractions in between 0 and 1. But for the sake of it being a fraction, I'm going to put the denominator as 9. So I'm going to scoot over a little bit. This is going to be 1 over 9, 2 over 9, 3 over 9, 4 over 9, 5 over 9, 6 over 9, 7 over 9, 8 over 9, and then this would be 9 over 9. And we know that 9 over 9 is equivalent to 1 whole, which is kind of blended into my line here, but this is 1. Okay, so 9 over 9 equals 1 whole. All right, so here's my number line. And if I start at 4/9, which I'm going to change my color here. If I start at 4/9, which is right here, and I were to jump 1 number, I know that I'll be at 5 over 9. So here is my sum, just like we added up here. Okay, so that's really all you're doing. All right, so for B, we're going to do the same thing. You have your number line here, okay, and our denominator is 4ths. Okay, so we've got 0, and then we've got 1. All right, so this would be 0 over 4. This would be 1 over 4. This would be 2 over 4. This would be 3 over 4. And 1 is equal to 4 over 4. So pretend that there are 4 slices of pizza, okay, and no pieces of pizza have been given out yet. All right, and say, say Johnny's getting 1, Claire's getting 1, Landon's getting 1. Whoops, I got the color wheel. That's not good. Landon's getting 1, and Dane is getting 1. All right, so we've got to hand those out first. So if I start at 0 over 4, and I'm adding 1, 2, 3, 4 ones, 1, 2 pieces are given out, 3, 4. So I know that I'm going to end up right here at 4 over 4, because 1 plus 1 plus 1 plus 1 equals 4 over 4. And I know that 4 over 4 is equivalent to 1 whole, just like this is. So that's how you would show that expression. Okay, so that's what you'll do for C and D. Now D is a little different. You've got a multiplication problem. I'm not going to do C, but because I feel like it's just like A and B. But D, we've got a multiplication problem here. Okay, you're going to start with 2 times 3 over 5. So that really means 3 over 5 plus 3 over 5. And then you're going to add plus 1 over 5. So when you draw this number line out, you're going to get an improper fraction. Okay, when you get that improper fraction, as you jump, or just like we did up here, you're going to have to convert some fractions into 1. Well, obviously, we know that we're going to start with 0. Okay? We know that our denominator is going to be 5. So once I hit 5 over 5, we know that this is equivalent to 1 whole. And then I'll have to keep going, more jumps. All right? And so you will get a mixed number, and you'll add up your whole numbers first, and then however many more jumps that you do to the right will be our fraction. Okay, whatever you land on. Okay, so if this is 1 over 5, 2 over 5, 3 over 5, oops, my pen's messing up, and 4 over 5, and then 5 over 5, this would be 6 over 5, 7 over 5, 8 over 5, 9 over 5, and then 10 over 5. And if you make it to 10 over 5, because there are 5 more after this 1, this is another whole. Okay? Now I'm not saying that this is the answer, but if you make it to this, then and then you keep going, then you would have to add the 2 whole numbers to get the large whole number, and then you would have a fraction here, so it turns into a mixed number. So see if you can figure that one out, okay? All right, so let's look at number 2. It says each fraction as the sum of 2 or 3 equal fractional parts. Express each fraction as the sum of 2 or 3 equal parts. So basically, and then it says rewrite the problem as a multiplication equation. You can show on a number line for part A. So what it wants you to do is look at the fraction that's given. So we've got 6/11. Okay, so what 2 numbers, because it says 2 or 3, what 2 numbers are equivalent to 6, or will equal 6, not equivalent? Well, my brain automatically goes to 3 plus 3, because I know 3 plus 3 is 6. So if I put those over 11 and keep the denominator, I know that I'll get 6 over 11. To change this into a multiplication problem, how many times did we add 3/11? We added it 2 times, so that's my whole number, times 3 over, color wheel again, over 11. And that will be 6/11. Because remember, I told you there's an understood 1 underneath that whole number. Okay, so show me that on a number line. And you're going to do that for all B, C, and D. Okay, you have to go through your multiplication facts for that one. All right, let's look at number 3. Express each of the following as the sum tells us that we're going to add, of a whole number and a fraction. Okay, a whole number and a fraction, this little phrase right here means that we want to express our answer as a mixed number. And it wants you to do C and D on a number line. So you've already done that. If you go back up here to number 1, this is what it's going to look like. Okay, so you'll have to figure out what the mixed number is. So if I wanted to do A for you, so for C and D, refer back to number 1, D, and that will be the exact steps that you follow. The only difference is you're coming up with the addition sentence. Okay, so I've got 9 over 5. Okay, well, I know that 5 over, no, excuse me, not 5. I know that, sorry, my screen shifted too. I don't know why that is. Let's see if I can move it. There we go. I know that 9 over 5 can be the sum if added by 3 over 5 plus 3 over 5 plus 3 over 5. Well, I know that that would equal 9 over 5. If I count by 3s, 3, 6, 9. Okay, but it wants us to represent it in a whole number and a fraction. Okay, well, we talked about this, and it's easier to see on a number line. So I'm just going to go ahead and do a number line, and you can do C and D that way. All right, so if 5/5 is 1 whole, This is 1 whole. And, you know, I've got 4/5, 3/5, 2/5. Sorry, I'm running into the other problem. 1/5, and then 0/5. Then I'd go 6/5, 7/5, 8/5, 9/5, 10/5. Okay, so if we're starting at 3, let's do blue. We're starting at 3, and we add 3 more. Okay, so 1, 2, 3. Okay, so that's 3/5. We've added 3/5. We've got to add 3 more fifths. 1, 2, 3. I end up at 9/5. Okay, so if you look right here, this is 1 whole. I haven't hit another whole number yet. My other whole is over here. I haven't made it there. So really, I have 1 whole number. Okay, and then when I get to my answer, I have to kind of backtrack and subtract 9 from 5. So if I do that, I go 1, 2, 3, 4. Okay, and the reason I did that is because I look at these two numbers and I subtract 9 minus 5. So really, my mixed number is 1 4/5. And that's equivalent to 9/5. Okay, so that's how you do B, C, and D. All right, really quickly, let's look at number 4. This is a word problem, so I really want you to kind of think about how to dissect this. But it says Natalie sawed 5 boards of equal length to make a stool. Each was 9/10 of a meter long. What is the total length of the boards she sawed? It says express the answer as the sum of a whole number and a remaining fractional units. Okay, that means whole number and remaining fractional units. That means a mixed number. Okay, and you can draw a number line to represent the problem. So our unit fraction is 9/10. It tells us that. Okay, so here's my number line. Okay, I know 10/10 is going to be 1 whole. All right, so we're going to do a multiplication problem here. If we've got 5 boards and we've got 9, and they're each 9/10 of a meter long, we're multiplying by a whole number. So I'm going to say 5 times 9/10. And this looks like what you created in your other problems. And remember, there's an understood 1 right here. Okay, so my denominator is still going to be 10, but 5 times 9 is 45. So 45/10. Now, that's a long number line to make. I get it. So when we talked about this too, about making a mixed number, we want to know how many times can I multiply 10 until I get close to or at 45. Well, that should be easy. Okay, 10 times 4 is 40. 10 times 5 is 50. It can't be over 45. So I know that the most I can get out of 10 is 4. Or 45 from 10 is 4. So then I subtract 40, because 10 times 4 is 40. 45 minus 40 is 5. And then I have the same denominator. So my answer in mixed numbers is 4 5/10. So I can write it that way, or I can go 9/10 plus 9/10 plus 9/10 plus 9/10 plus 9/10. And that would give me 45/10. Okay, so it's hard to show on a number line, but if you need to use that, you can. So I hope this helps you, okay? Be prepared to turn that in tomorrow.